Hey yo, it's me, Frank, the function fighter, talking to you about relations and functions. Now here's a question. What do you call a pig who knows karate? That's a pork chop! Yeah!
First vocabulary term is an independent variable. It's a variable, often x, that represents a quantity that is being manipulated. So in this section, we're going to talk about independent variables and dependent variables. An independent variable is something that we are going to manipulate. And in this section, it's likely going to be either x or t for time. So in an equation, what happens? We usually have that equation solved for one variable. What we do is we're going to plug in a value for x. And when we plug in something for x, we then simplify this side over here and we get a value for y. And you can see that y depends on whatever we plug in for x, meaning that as we plug in different things for x, we get different values for y. So y is something called our dependent variable, whereas x, in this case, is our independent variable because we are plugging in values for x and getting values for y. Here in our table, the left column is usually going to be your independent variable, whereas the right column is usually going to be your dependent variable. In a graph, the independent variable is usually your x-axis here. Now the dependent variable, we kind of just mentioned this, the dependent variable is a variable, often y, that represents a quantity that depends on or is affected by the independent variable. So here you can see we have our equation solved for y, and what happens is we're going to plug in something for our independent variable, x, then we simplify this expression right here, and we get what y is equal to. Now, y depends on whatever we plug in for x. Therefore, y is called the dependent variable in this case. And when we have a table, it's usually the right side, the right column is going to be your dependent variable. And on a graph, the y-axis is usually going to be your dependent variable. Now let's go to some new vocabulary. An ordered pair. It's the coordinates of a point in the plane. So they're usually denoted by an x value and a y value. And here you can see in between two parentheses, we have a 7, -2. The 7 represents the x coordinate, whereas -2 is going to be our y coordinate. This tells you where to plot a certain point on the coordinate plane. A relation is going to be a set of ordered pairs. So when you have multiple ordered pairs that we're going to graph on the same graph, that would be called a relation. Next, the domain is going to be the set of all x coordinates of the ordered pairs of a relation. So here you can see we have this relation, the set of ordered pairs. And what we're going to do, it says given the relation 8, 1, -1, 2, and -5, -6, state the domain. Well, the domain, again, is just the set of all the x coordinates of the ordered pairs. So when we state the domain, it's just going to be 8, -1, -5. And that would be the domain of this relation. Now, one thing I'd like you to keep in mind is that when you graph something, the domain is going to be represented by all the elements on the x-axis, the horizontal axis. Now the range is going to be the set of all y coordinates of the ordered pairs of a relation. So here we can see given the relation, and we have the same relation as before, we have the same set of ordered pairs, state the range. Now this is going to be all the set of y coordinates. So 1, 2, -6. That's going to be your range. And again, if you're thinking about a graph with an x-axis and a y-axis, the y-axis is going to represent all the elements of your range. Now, a function is going to be a relation or a rule in which each element of the domain is paired with exactly one element of the range. Now, if we look at these examples down here, the first one says the relation 8, 1, -4, 1, and -5, -6 is a function because each x coordinate is paired with only one y coordinate. Each x coordinate is paired with only one y coordinate. Now, you can see that the 8 is paired with the 1 and the -4 is also paired with the 1. That's okay, as long as you don't have one x value paired with multiple y values. Now the second one over here, the relation 7, 2, -2, 3, and 7, -6 is not a function because 7 is paired with more than one y coordinate. You see how we have 7 paired with the 2 and 7 paired with the -6? The reason why that is not a function is because we have one x value paired with multiple y values. You're allowed to have one y value paired with multiple x values, just not one x value paired with multiple y values. Now, a function rule is a relationship between input and output values. To find the function rule, we have to observe the given data carefully and find how input and output values are related to each other. So here you can see our input values for each of these equations would be x here, a here, c here, and x here. Those would be values that we plug in numbers for, our independent variables, our input values. We're going to get out our output values, our dependent variables. So that would be y, b, y, and w. Those represent our output values or our dependent variables. Now, in terms of linear and nonlinear functions, we're going to talk about this in a second, but I want you to note, looking at the function rule, a linear function, those independent variables have an exponent of 1, x to the first power, a to the first power. That's for a linear function. For nonlinear functions, you're going to have exponents that are not equal to 1 for your given independent variables. Here, our independent variable c has an exponent of 2. Here, x is actually our exponent in this case. Both of these represent nonlinear functions, meaning that their graphs would not be straight lines. These graphs would be curves, whereas the graphs of these function rules would be lines. Now let's get into linear and nonlinear functions a little bit more. A linear function is a function whose graph is a non-vertical line or part of a line. On the flip side, a nonlinear function is a function whose graph is not a line or part of a line. So here you can see our linear functions form lines or parts of lines. Our nonlinear functions do not form straight lines. They are more curves or crooked lines or V's or S's. They are nonlinear functions. Linear, nonlinear, makes sense, right? Linear forms a line. Nonlinear does not. Our Cartesian plane or coordinate plane looks like this. If you forgot, here we have our coordinate plane where quadrant 1 is in the upper right, quadrant 2 is in the upper left, quadrant 3 is in the lower left, and quadrant 4 is in the lower right. Our x-axis is the horizontal line and our y-axis is the vertical line, and the point at which they meet is called the origin.
Why didn't the dog want to learn karate? It was a boxer! It's example time.
Now example 1 says graph each relation on a coordinate plane. Describe the pattern shown in the graph. So we're going to graph each of these points on this plane. So 0, 0, that's our origin. So that's where the x-axis and the y-axis cross. So we're going to put a point at the origin. 1, 1. Remember, this is our x-coordinate. This is our y-coordinate. So we're going to go over 1 on the x-axis. We're going to go up 1 on the y-axis and put a point. That's 1, 1. 2, 2. We're going to go over 2 on the x-axis and then up 2 on the y-axis and put a point. 3, 3. We go over 3 on the x-axis and then up 3 on the y-axis, and we're going to put a point. Boom. We have our relation graphed. Now, how do these relate to each other? Well, you can see when x increases by 1, y also increases by 1. Part B, we have these points that we're going to graph on this coordinate plane. So first, we have -2, 0. Again, x coordinate, y coordinate. So -2, we're going to go over to -2 on our x-axis, and then we're going to go up or down 0 on our y-axis. So that means we're not going to go anywhere. We're going to go over to -2, and we're going to put a point. That is -2, 0. -1, -2 means we're going to go over to -1 on our x-axis, and then -2, we're going to go down 2 on our y-axis and put a point. 0, -4 means we're going to go over 0 on our x-axis. We're going to go down -4 on our y-axis. So we're going to put a point. 1, -6 means we're going to go over 1 on our x-axis. And then our y-axis, we're going to go down 6. And we're going to put a point at 1, -6. Now the relationship between these points, you can see as x increases by 1, y decreases by 2. Increase by 1, decrease by 2. Increase by 1, decrease by 2.
What do you call a flying squirrel and a moose who can box? Rocky Balboa and Raging Bullwinkle. You try.
Okay, for the first one, again, 0, 0. We're going to graph this. So 0, 0, that's our origin. So we're going to put a point at where the x-axis intersects the y-axis. Now 2, 3. This is our x-coordinate. This is our y-coordinate. So we're going to go over 2 on the x-axis and then up 3 on the y-axis and put a point. Again, this is our x-coordinate, this is our y-coordinate, so we're going to go over 4 on the x-axis and up 6 on the y-axis, and we're going to put a point. And then 6, 9, we're going to go over 6 on the x-axis and up 9 on the y-axis and put a point. Now, how are these related? What's the pattern? Well, it looks like as our x increases by 2, our y increases by 3. Increase by 2 on the x, increase by 3 on the y. Increase by 2 on the x, increase by 3 on the y. Yep, that's how that works. Over here, we're going to graph each of these separately. Again, x-coordinate, y-coordinate. So we're going to go over to -4 on the x-axis, and then we're going to go up 3 on the y-axis, put a point. negative 2, comma 3. We're going to go over to negative 2 on the x-axis, up to 3 on the y-axis, put a point. 0, comma 3. We're going to go over 0 on the x-axis and up 3 on the y-axis, put a point. And then we're going to go over to 2 on the x-axis, up 3 on the y-axis, put a point. Now, how are these related? Well, it looks like as x increases by 2, y doesn't increase. It increases by 0. So we could say that when x is any number, y is going to be 3, right? At any x value that we were to pick, y is going to be 3. Okay, example 2 says for each table, determine whether the relationship is a linear function. Then represent the relationship using words, an equation, and a graph. So here we have our table, and we're first going to decide, is this a linear function? Well, in order to be a linear function, all it has to be is a straight line when we graph it, which means as long as the x increases by the same amount and the y is increasing by the same amount, we can say, yes, it's a linear function. So here, the x is increasing by 1 each time. Now the y is increasing by 1 each time. So these are increasing by the same amount, so that checks out for the y. Yes, this is going to be a linear function. It's going to form a line. Next, the relationship using words. As x increases by 1, y is also increasing by 1. This is getting more and more positive. Next, the relationship using an equation. You first always write y equals. And then on the other side, I'm going to do something to x in order to get y. The question is, what do you do to x to get y? What do you do to these x values to get these y values? Well, you always try just adding or subtracting something first. So can I add or subtract something to get negative 4? Well, I can subtract 4, right? What's 0 minus 4? That's negative 4. Let's try that here. What's 1 minus 4? Negative 3. What's 2 minus 4? Negative 2. Oh, it works. 3 minus 4 is negative 1. So I'm going to write my equation y equals whatever the x value is, x minus 4. And that makes sense, right? I can now plug in each of these x values and I will get their corresponding y value. If I plug in 0 for x, 0 minus 4 is negative 4. Now, my relationship using a graph, what I'm going to do is I'm going to graph each of these points as an ordered pair. So this is 0, comma, negative 4. So I go over 0 on my x-axis, down negative 4 on my y-axis, put a point. 1, comma, negative 3. I'm going to go over 1 on my x-axis, down negative 3 on my y-axis, put a point. 2, comma, negative 2. I'm going to go over 2 on my x-axis, down negative 2 on my y-axis, put a point. And 3, comma, negative 1. I'm going to go over 3 on my x-axis, down negative 1 on my y-axis, put a point. You can see these form a straight line. So yes, this is a linear function. A couple key things I want you to remember for the coming tables that we're going to do. This 0, comma, negative 4. This is going to make an appearance in your table, in your equation, and in your graph. Notice that it's where the graph crosses the y-axis. Wherever the graph crosses the y-axis, that's going to be 0, comma, your number. And this number, anytime we have y equals for our equation, is going to be on the other side of the equation, and it's going to be added or subtracted to whatever our x is. So here, you can see because it's 0, comma, negative 4, we have y equals x minus 4. It's tacked on at the end, and it's where the graph crosses the y-axis. Also, this number in front of x is going to be determined by this right here. The number that we put in front of x, that's going to be something called the slope, and we'll get to that later on. But this number in front of x is going to be whatever the y increases or decreases by, so that'd be 1, over whatever the x increases or decreases by, so that would be 1. That's why here we end up getting the number in front of x is 1 over 1, which is 1.
Why did the black belt get arrested? Because he held up a pair of pants. You try.
Okay, again, first deciding if it's a linear function. Is it a linear function? Well, it looks like x is increasing by 1 every time, and y is increasing by 2 every time. Because each of them is increasing by the same increment each time, we say, yes, this is a linear function. If this were to go from 1 to 3, and then from 3 to 6, and then from 6 to 10, they wouldn't be increasing by the same amount every time. Therefore, it wouldn't be a linear function. But since it's increasing by 2 every time, it is a linear function. Next, the relationship using words. We just said as x increases by 1, y is increasing by 2. And then a relationship using an equation. We're going to start with y equals. And then on the other side, we need to figure out what are we doing to x in order to get y. Well, again, let's try like last time. You always try adding or subtracting something first. So here, to get from 0 to 1, I would add 1. Does that work here? Well, what's 1 plus 1? 2. No, that's not 3. What's 2 plus 1? 3. That's not 5. Okay, that's not working. That means that we need to multiply something by x and then possibly add or subtract something. So let's see. If I multiply x, let's say, I don't know, let's try 2 first. If I multiply this by 2, what do I get? I get 0. Well, then I would have to add 1 in order to get 1. So, okay, let's try that. 2 times 0 plus 1 gives me 1. What's 2 times 1? 2. Plus 1 gives you 3. Okay, that works too. What's 2 times 2? That's 4. Plus 1 is going to give you 5. Okay. 3 times 2 is 6. Plus 1 is 7. So I think we found it. We got y equals, and then we're we're going to multiply x by 2, so it's going to be 2 times x, and then we're going to add 1, and that will give you the y values. Awesome. Now, on our graph, we can see that we're going to plot each of these points, so 0, 1, we go over 0 on the x-axis, up 1 on the y-axis, put a point. 1, 3, we go over 1 on the x-axis, up 3 on the y-axis, put a point. 2, 5, we go over 2 on the x-axis, up 5 on the y-axis, put a point. And then 3, 7, we go over 3 on the x-axis, up 7 on the y-axis, put a point. You can see, yes, it is a straight line, therefore, yes, we were right in determining it was a linear function. Also, recall this guy right here. Remember, 0, 1. That's why we have this 1 tacked on at the end. That's not an accident, and that's why that's where the graph crosses the y-axis at y equals 1. Not an accident. Also not an accident. The number in front of x is going to be whatever the y increases or decreases by, 2, over whatever the x increases or decreases by, 1. So we have 2 over 1. That does equal 2. That's the number in front of x. Weird. We're going to use that in the coming lessons when we get harder tables to solve. So example 3, let's jump right into it. Doing the same thing. First, is it a linear function? Well, let's check. X is increasing by 1 every time. Y is decreasing by 5. And since it's the same amount every time, yes, it is a linear function. Next, what is the relationship using words? So we said as x is increasing by 1, y is decreasing by 5. After that, we have to do our relationship using an equation. So we start with y equals. And now what do we do to x to get y? Well, let's see. First, always try adding or subtracting something. So how do I get from -2 to 5? I would have to add 7. So if I add 7 to -2, I would get 5. If I add 7 to -1, no, that doesn't make sense. So that one doesn't work. That means I have to multiply something by x. Let's use the cheat codes we were just talking about. So in our cheat codes, we said that we're going to have a number multiplied to x. And that number is going to be whatever the y increases or decreases by over whatever the x increases or decreases by. So here, y is decreasing by 5, meaning this is going to be -5 over whatever x increases by. So x is increased by 1, so it would be -5 over 1. That's going to be the number that we multiply to x. Now the question is, what do we add or subtract at the end? Well, remember, that's going to be our y-intercept. That's going to be where the graph crosses the y-axis. That's 0, whatever number this is. So here it's -5, meaning that both of these numbers are actually going to be -5. So it's going to be y equals -5 times x minus 5. Sweet. Now we can graph this. So we're going to graph each of these points separately. So we have -2, 5. We're going to graph that. We go over -2 on our x-axis and up 5 on our y-axis, put a point. We have -1, 0. We go over -1 on our x-axis, up 0 on our y-axis, put a point. 0, -5. We're going to go over 0 on our x-axis, down -5 on our y-axis, put a point. And then 1, -10. We go over 1 on our x-axis, down -10 on our y-axis, put a point. You can see these all form a straight line. Therefore, it is a linear function. And this -5 and our y-intercept all match up with our table, so it all checks out.
I could have been a contender. You try.
Okay, doing the same thing. First, is it a linear function? So here, the x is increasing by 2 every time, so that's the same amount. And y is decreasing by 3 each time. So yes, that is also the same amount, meaning yes, this is a linear function. Next, relationship using words. We just said, as x is increasing by 2, y looks to be decreasing by 3. Now let's do our equation. So we have y equals, and you always try to add something to x to get y first. So it looks like in order to add something to -4 to get 9, I would have to add 13 to x to get y. Does that work here? If I add 13? No. So obviously I'm multiplying something by x and then adding or subtracting something to get y. So how do I figure that out? Well, again, we start by figuring out what are we multiplying to x, and that comes from these guys right here. Y decreases by 3 over x increases by 2. So what does y decreases by 3 mean? That means we're going to have -3 over, and then x increased by 2, a +2. So -3 over 2 is going to go in front of our x, so we're going to have y equals -3 over 2x. And then what do we add or subtract at the end? We add or subtract our y-intercept, 0, whatever this is. This is going to be our y-intercept, meaning that is what we're going to add at the end of our equation. That's why that is there. Next, we can graph each of these. So -4, 9. We go over -4 on our x-axis, up 9 on our y-axis, put a point. We go over -2 on our x-axis and up 6 to graph -2, 6. And then 0, 3, we go over 0, up 3 on our y-axis, put a point. And then 2, 0, we go over 2 on our x-axis, up 0 on our y-axis, put a point. Yes, these are all in a straight line. Therefore, we did this correct. We named it a linear function. And you can see, boom, our y-intercept is at 3, just like each of these tell us. Now, a word problem. It says an automaker produces a car that can travel 40 miles on its charged battery before it begins to use gas. Then the car travels 50 miles for each gallon of gas used. Represent the relationship between the amount of gas used and the distance traveled using a table, an equation, and a graph. Is total distance traveled a function of the amount of gas used? What are the independent and dependent variables? So let's start by making our table, because that's what it wants us to do first. In our table, we're going to have two columns. What are our two columns going to be? Well, it says it can travel 40 miles on its charged battery before it begins to use gas. And then the car travels 50 miles each gallon of gas used. Interesting. So each gallon of gas used, we travel a certain amount of miles, meaning I feel like our X is going to be the amount of gas that we use, and our Y is going to be the distance that we travel on that gas. There we go. We now have our table. If I go with 0 gallons of gas, how far can I travel? Well, it says 40 miles is how far we can go on a charged battery before it begins to use gas. So before using any gas, 0 gallons of gas, you can travel 40 miles on that battery. Then after you use 1 gallon of gas, how far can you go? Well, it says the car travels 50 miles for each gallon of gas used, meaning that if we use 1 gallon of gas, we could travel 50 miles on that. But we already started with our 40 miles, right? With 0 gallons of gas, we drove 40 miles. Then on top of that, we used a gallon of gas to travel another 50 miles. So this should be 40 plus 50, which is 90. Next, we use another gallon of gas and we travel another 50 miles. What's 90 plus 50? That's 140. We use another gallon of gas and we travel another 50 miles. Sweet, we have filled out our table. Next, the relationship using words. So it looks like as the numbers of gallons of gas that we use increases by 1, the distance traveled increases by 50 miles. Next, our relationship using an equation. So let's say gallons of gas used, that's going to be our X. Distance traveled, that's going to be our Y. So we start with Y equals, and now we need to figure out what do we do to the gallons of gas to get the distance traveled. What are we doing to this? Well, we always try adding something or subtracting something first. So from 0 to 40, looks like I add 40. Does that work here? What's 1 plus 40? 41. No, that is not 90. So obviously we're having to multiply this by something to get this over here. Well, what are we multiplying by? Let's think about our cheat codes. Remember what we were doing before? We used the amount that the Y increases or decreases by over whatever the X increases or decreases by to get the number that we put in front of our X value. So it's going to be Y equals. Now what does our Y increase by each time? That's 50. And what does our X increase by? That's 1. So we're going to, in front of our X value, we're going to put 50 over 1. Now the question is, what do we add or subtract at the end of our equation? Well, remember, that's going to be whatever the Y-intercept is, wherever the graph crosses the Y-axis. Now where does the graph cross the Y-axis? That's going to be at 0, whatever number that is. And in our table, we see it. That's 40. This is going to be where the graph crosses the Y-axis, meaning that's the number we add at the end of our equation, as you can see here. Now we have an equation, Y equals 50x plus 40, where we could plug in any number of gallons of gas for X, and we would get the distance traveled with Y. If we were to simplify it out, it works for every single one of these X values. Sweet! Now what we can do is graph this. Now how do we graph it? Well, the independent variable is the variable that we change every time. So we are changing the amount of gas because we are using a different amount of gas every time. So that's going to be our X value. And that would make the distance traveled our Y value, because the distance traveled depends on the amount of gas used, meaning the distance traveled is the dependent variable and the amount of gas used is the independent variable, meaning that yes, the distance traveled is going to be a function of the amount of gas used. Now all we have to do is graph each of these points separately. So 0, 40, we go over 0 on our X-axis, up 40 on our Y-axis, put a point. So these are going to be in tens of miles. So that would be at 4 right here. 1, 90 means we go over 1 on our X-axis, up 90 on our Y-axis. Since these are in tens, it would be at 9. And then 2, 140, we go over 2 on our X-axis, up 140 right here, put a point. And then 3, 190, we go over 3 on our X-axis, up 190 on our Y-axis, and we put a point. You can see these are all in a straight line, meaning yes, this is a linear function, and we did it right because you can see our Y-intercept is at 40, just like we said here. And the slope, this number in front of X, is Y value changes by 50 when the X value changes by 1. So the Y value increases by 50 as the X value increases by 1. Y value increases by 50 as the X value increases by 1. So that's something we're going to get into further. The slope is something we're going to describe later, just like the Y-intercept is also something we're going to get into more later. For right now, just take away these helpful hints in order to create your equations from these tables.